Hi, and welcome to another brewpub video. In this video, I'm going to be showing you how you can build your own mill for your brewpub or your microbrewery. Mills are available commercially, of course, but they often start at about $3 or $4 grand and go up. This mill I put together for about just under $1,000 in parts, and maybe a long afternoon it took me to build it. So I'm going to go through the various parts, and then I'm going to go into more detail about how to build it, and then I'm going to show it to you in operation. So first off, what I needed to source was a table. I went with a wooden table because it's easier to drill holes through, to put the, to mill, to be able to drop the grain through. I wanted to put some extra supports in just to strengthen it, and so wood was useful for that. This is an old table. It came out of a community hall that had listed it on the used website, and you can see that the plywood here is pretty close to a true 1 inch. So it's a real rugged old table, and of course, if you're going to be putting extra weight on it, you need it to be strong. I like to with wood as well because I can adjust the width of it. With a metal table or a plastic table, you can't really adjust it at all. But with a wood table, you can take the legs off, you can move them in, you can cut them off. It's a lot easier to fit into different sizes, different locations that you might have. So the first thing I did with the table was I bought some 1.5-inch angle iron, and I just ran it along the wooden runner underneath to give it some more strength. Because I have it so wide right now in the middle with all this weight with the motor and the reducer and the mill and the grain, it could sag a bit. So that angle iron on the front and the back added some rigidity. The angle iron was about $20 just at a local metal shop. And I drilled holes through the angle iron, up through the wood. Once the holes were drilled in the angle iron, I could mark it on the wood, drill through, and then I put bolts through just to hold 4 bolts on the front and back, just to hold that angle iron in place. And I recessed the bolt at the top so that it's not sticking out, so if you run your grain bag over it, it's not going to rip it open. This is a Crankandstein mill. I really like their mills. They're $400. It's an 8-inch 3-roller mill. It's adjustable in 0.05-inch increments with a click. So it's really easy to tell where you're at. You just loosen the bolt off on the front and the back, and you can run it through the different sizes. It is also, one of the really neat things about this mill is that it's fully geared. It's the only one that I know of presently on the market that's fully geared, which means that all 3 rollers have teeth that connect into each other, so that when the motor is driving the one roller, all 3 automatically start turning, and you don't get that shearing action and the binding action that you would get with a single drive roller. So that's a really neat feature. Along with the Crankandstein mill, I also got this top board and bottom board. You could easily build those yourself, but they offered them for $20-30, something like that. They have a little hopper which came with it as well, but I didn't want the hopper because I went with this Monster Mills hopper. Here's the hopper, and here is, of course, the extender. You can put in, I think it's about 20 pounds of grain at a time, so pretty close to half a bag that you can add in. The larger hopper size is nice because you don't just have to sit there and feed it all the time. The bolts came with the Crankandstein, so the top went on. I had to add these sides, which I just used roof flashing from Home Depot. It didn't come with any sides on it. Maybe they will start offering that, I don't know, but I just used roof flashing, $5-10 at Home Depot, that I just drilled a hole out so the bolt would go through. And of course it has that bend in it, being flashing, so that it goes over the top. I just cut it back enough for the hole so that it stays into place. One more thing that I want to show you on this side before we start to look at the other is just the switch that is mounted there at the back to turn the motor on. So here's a box. We just mounted it on the wood. We needed to adjust the motor height so that it would line straight into the reducer. And on the side, we've just mounted a switch, just a simple switch that feeds into the motor. It's a 120 horse motor, which goes into our wall. And it's just easy then to turn the mill on and off. So looking at the setup of the mill, there are 2 main ways that you can assemble the mill. The first is to have a motor going to a reducer to a belt. The second is go from the reducer directly into the drive shaft of the motor. There's benefits to both. I think most people go directly from the drive shaft or the speed reducer into the drive shaft of the mill. That ensures that the torque going into the mill is direct, and it also means that there's no potential for slippage in the belt. The benefit of using a belt is that there's a little bit more safety in that if something jams into the mill, the belt is more likely to slip, whereas if it's a direct drive, then it's more likely you're going to damage your motor. I'm going to go through both modes of operation or setup. So first we'll look at the belt. How we have it assembled is we have our motor, which is a 1 horse, 120 volt, not 120 horse, 120 volt motor. Recommend that being the smallest. A horse and a half is also good, wouldn't go any smaller than a horse. Here are the flex couplings that attach to the motor, and there's a flex coupling onto the 10-to-1 speed reducer. In between the two flex couplings is what's called a spider. It's just a rubber piece that goes between the two to take up some of the shock when the motor starts up. Coming off of the 10-to-1 speed reducer, there is a sheave that attaches to the speed reducer, and another sheave. I have 3 inches diameter on both of these. If you go a little bit larger, it gives more surface area. So I wouldn't go any smaller than 3, but if you use a 4 or 5, it gives more surface area on the belt, so there's more friction, and you're more likely to have proper grip. If you are seeing that the belt is slipping, there are these tensioners that need to be installed in order to force the mill over and keep the belt tight. When you put these bolts down to hold the mill down to the table, I used a router bit and did about a 1/2 inch oval shaped groove so that in the table these bolts can actually move back and forth and there's a bit of play. When I first positioned it and tensioned the belt, of course I had everything on this side of those holes, and then these tensioners can push it over a full 1/2 inch in order to take the slack out of the belt. These are just brackets that I found at the hardware store. They were a couple bucks each with bolts through to hold them down. This bolt can be tightened. As you tighten with the nut, it's going to push this over against this bracket that's attached to the mill mount here, and it's going to push it all over. And once you've got it tightened again, you can tighten down the bolts here and hold it snug. It's important not to over tighten though, because you're going to be putting a lot of tension onto the bushing that is holding the mill in place if you're constantly pulling it tight, and you're going to wear that bushing out a whole lot faster. So with a cutout, I cut out the size for the mill underneath, and I attached it was just actually ducting for a floor duct for heat, air heat in houses, and that duct then goes down to it was a 4-inch outlet, which then you can connect your grain bag to. The grain bag's on a pallet. You can just move it underneath with a small pallet jack, connect the top chute of the loading chute on the grain bag to that outlet, which is focusing the grain down into the bag. Once you're done milling, then you just use your pallet jack to move your pallet with the grain bag over to your hoist. It goes up the hoist, over top of your mash colander, and you unload your grain in it. So this is the one way to assemble it using a belt. Now I'm going to look at how to assemble it using a direct drive into the mill. Okay, so I have switched it all over. It didn't take very long to do that. And now the speed reducer is directly connected to the drive shaft of the mill. These tensioners are no longer in play, so if you set it up this way, you don't need to install these. I'm going to move the camera over to the other side so we'll be able to see it a little better. So from this angle you can see it a little bit better. We have flex couplers going from the motor into the drive shaft with the spider in between, and the same thing is from the reduced shaft on the speed reducer going into the mill directly with the spider in between as well. So I'm going to put some grain in, and we're just going to show you how it works. Down at the bottom we've connected the bag to the chute. We've just used a rubber band just to tie it around the chute, and so the grain, when it dumps out of here, it goes directly into the grain bag. And that's it. That's how to build your own grain mill for your brew pub or your microbrewery. If you have any questions, feel free to send them in using the form on the website. Thank you for watching.